Okay, welcome to our last installment of discussion for stoichiometry. The last thing that we need to talk about is percent yield. So what percent yield is it determines what percent of products were actually formed versus what we expected. So what we've been calculating so far in our BCA tables is the expected yield. That's what we expect to make. Just like on a recipe, it'll say yields 12 blueberry muffins, for example. Well, when you start putting it out in the cups of the little muffin tin, sometimes you don't end up with 12. You only end up with 11 because maybe you filled them too full or some of it fell on the floor or something like that. So your yield there would be less than what you expected. Your actual would be less than what you had expected versus what the recipe card had said. So the formula for this, and it looks like this got kind of scooted over, but it should be actual yield over theoretical times 100. And actual yield is how much you actually got. That would be your 11 muffins. And theoretical yield is how much you should have gotten, which would be your 12 muffins, what your recipe card said. So these all start out the same way as they did with our other stoichiometric calculations. We start out with a balanced equation, so we can figure that out. Here we've got chlorobenzene. We're producing that, so it's going to be one of our products. We're making that from this benzene and chlorine, and we're forming chlorobenzene and hydrochloric acid. So we need to start out with a balanced equation first. So C6H6 plus Cl2, remember chlorine is a Brinkelhoff, forms our chlorobenzene, C6H, that's starting again. C6H5Cl plus hydrochloric acid. All right, so make sure that this is balanced. It's already balanced. We're going to take our amount of benzene here. We're going to divide it by the molar mass of benzene to get it into moles. So the molar mass of benzene is 78. So we're going to divide that by 78. That gets that into moles, and that is 0.472. This, we're assuming, they said in our problem that we have an excess amount, and in the beginning, we don't have any of these formed. So we're going to use all of this up. And we're going to form 0.472 over here. And we'll still have an excess amount left over here. And we won't have any of this left. All right, so this is how many moles we should make of this. So we're going to take 0.472. We're going to multiply that by the molar mass of chlorobenzene, which happens to be 112.5. And that's going to tell us that we should have made 53.1 grams. Now, they tell us in our problem that we actually only made this many grams. So they want to know what our percent yield is. So we're going to take our actual amount here, which is 38.8. We're going to divide that by our theoretical yield down here, which is what we just calculated. And multiply that by 100. And when we calculate that out, we end up with 73.1% yield. All right, next problem. Here we have potassium chromate. We are reacting that with silver nitrate. We're forming silver chromate, and they want to know what the theoretical yield is, and then we'll have to calculate the percent yield after that. So starting out with our balanced equation here, we are going to have our potassium chromate, so 2CrO4. We're going to react that with our silver nitrate. And we're going to form potassium nitrate and silver chromate. Need to balance our equation here. So I'm going to put a 2 here and a 2 here, and that'll get it balanced. And then we're going to calculate how much we have. We're starting out with 0.50 grams of silver nitrate. So we need to convert that into moles. So we're going to divide it by the molar mass of silver nitrate, which is 169.9. And when we do that, we find out that we have 0.00294 moles. This, we are assuming that we have excess since they didn't tell us any amount there. And when we begin, we don't have any of these to start out with. All right. So make sure when you're filling out these BCA tables that you always keep 3 significant figures in the BCA tables at all times in order for your calculations to come out properly. So remember, zeros at the beginning of a number are never significant. So when we start out here, we're going to use, we need to take this up into the cloud here. And when we take it up into the cloud, we're going to divide by 2. So when we divide by 2, our cloud becomes 0.00147. And when we bring it back down through the cloud, we end up with 0.00147. Shh, go lay down. Go lay down. And when we complete our table here, we're going to use up all of this. So we don't have any of that left. Over here, we're going to bring this down through the cloud. We still have an excess amount. And over here, we're going to form 0.00294. And 0.00294, 0.00. All right, so now we know how many moles of this we're going to make. We need to figure out grams for that. So 0.00147, we're going to multiply that by the molar mass of silver chromate, and that is 331.7. And we end up with 0.488 grams of this actually or theoretically formed. In actuality, so that takes care of that problem up here. So 0.488 grams. In actuality, we only ended up making 0.455. So 0.455 over 0.488 times 100. And we end up with 93.2% for our answer for our percent yield. So 93.2%. All right, one more problem here. Here we have aluminum hydroxide, and we're going to react that with hydrochloric acid. It's going to form aluminum chloride and water. So write our equation down. They've already balanced it for us. All right, we need to figure out the moles of this. So moles of that, we're going to divide this by 78, which is the molar mass for aluminum hydroxide. When we do that, we end up with 0.179. If we take that and we multiply it by 3, then that's going to be 0.537. Oops, I guess this is in the beginning, so that would be 0, 0. We're going to form 179 here and 0.537 here. We're going to use up 0.537, and this would have actually been excess to begin with. And then down here, we're going to use up 0.179. Here we'll have excess remaining. We won't have any of this left. 0.179 and 0.537. All right, so we're going to take this value and we're going to convert that into grams. So 179.179 times the molar mass for aluminum chloride, which is 133.5. And we end up with 22.0 grams. No, I'm sorry, that's wrong. We end up with 24 grams for this one. So this is 24 grams when we multiply that out. In actuality, we had 22 grams. So 22 divided by 24 times 100 equals 91.7% yield. And that's how we do percent yield problems.